Hello all, welcome to another LeetCode problem. So today we are going to look at a problem number 1367, linked list in a binary tree. So in this problem we are given a linked list as well as a binary tree as well. So and then we need to determine if the linked list that we have is actually present as part of one of the paths in the binary tree. So example, in this one you are given linked list as a 4 to 8, and then this is your entire tree which is given here, and then you need to see if the 4 to 8 as a path exists in a binary. So it could be on the left hand side, it could be on the right hand side, it could be anywhere, but they are connected, they are not disjoint path, so they are connected path from top to bottom. And then if you find a path, then you just return true, otherwise you return false. For example, this one also there is a path from top to bottom, so one is basically ahead of the linked list, and then this is a path that is next node is 4, next node is 2, and the next node is 6. It is not like 1 4 is there and 2 6 here. They are not there, so there has to be connected, and there is a dedicated path for the linked list, right? Now how do we solve the problem? So we will take a simple example here. So this could be quite complicated to understand and solve the problem. So we are going to use basic depth first search, and then we'll traverse the linked list from left to right. So in this problem it is given that you have a linked list which is, let's say, 2 3 4, and then your head is pointing to this particular node, right? And then this is your binary tree which start from 1. So you have 1 2 3 4 and then 5 8. So you have a path something like 2 3 and 4, and there is a path exists, right? So we'll use recursion, and then let's see how we can solve the problem. So what we have to do is, as we have to find the head node first in the tree. So when I start from the 1, so I see this 1 is not equals to my head node. Head node is what? 2. So it is not equals to, I'll just go ahead in the left hand side or either on the right hand side, because then 2 can be present on either side, right? And then if I don't find, let's say, right hand side, I don't find, then this is not equals to 2 as well. So and I'll do a further traversal. So as soon as I reach, this is also not equals to, so I reach a uh, leaf node, there is nothing to traverse. So if root is becomes null, then I'll return false. So this will return false, this will also return false, this is also return. So in this side, right hand side, there is, I didn't find any node matching to my head node, right? But as soon as I traversing on the left, so I see there is a match here. Now as soon as I find match, I'll invoke other recursion to see if there is a path exists or not. Now this is my starting point now. So I find, okay, I find there is a match here, so I'll move my pointer to the next pointer. Now head will point to the 3. So now I see if the either left hand side or either on the right hand side I have a 3 as a node present. So right hand side there is nothing out here. So as soon as I hit the null node, root is null, I'll return false here. So we have to think as, so when root is null, I'll return false. But when my head becomes null, so basically if I reach to end of the head, then I'll return true. So here my root becomes null, so I'll return false here. And then I'll do on the further go tree in the down, I do the tree traversal and go down the tree. So I find head dot next is what? 3. So head is pointing to this particular node, so 3 is equals to 3. So still there is match, there is a hope that I can still find the complete list in the tree. Now again I do further left side traversal and the right side traversal. So here I reached here, so I see 4 is not equals to 7. So in this case I'm going to return false because I didn't find a match here. But when I go to the right hand side, I see 4 is also present, so 4 is equals to 4, and then there is nothing here to traverse. So I reach to the end a leaf node, and also when I do a head dot next, I'll reach to the null. So when head becomes null, so I have to return true. So from left hand side I'm returning false, and then from the right hand side I'm returning true. So false and true. So if I do OR on this, I'm going to return true, because false and true, if I doing OR operation, so it will return true. Now remember earlier false was written for this particular left hand side, and then true will return from this, so it will go as a true. And then here also it is left, is from the left I'm getting false because nothing, I couldn't find it. And then from the from the right I'm getting false, from the left I'm getting true. So true or f, that's going to be true. So I can see that there was a path in the tree, which is completely present uh, in this particular thing. So the path was 2 3 4. We don't need to return the path, we just need to tell whether it is present or not, and based on the list node traversal. So what we have to remember is we have to find first where is the head node, and then once I reach the head node, I keep doing head dot next to visit the next node in the list, and then I do further go down in the tree to find whether the head dot next matches to the root node or not. So that's the logic here. Let's look at the code here. So so I have two recursions. So one recursion basically which do the tree traversal, yeah, just to see if you find anywhere which is head is basically equals to root. And then second helper function I have that basically keep traversing in the tree, and then if the head matches, then I'll do further traversal, otherwise by default I'll return false here, right? And as I mentioned, if head is null, then I'll return true. If root is null, I'll return false. So basically I didn't find any matching criteria. So I start with the root node here, which is let's say 1, and then head here. So if I go, this is 1 and head is 4 here. So I didn't find, so it is not equal. So basically your 1 is not equal to 4. So by default I return false. So it is written false. It came out here, and then it will further do a tree traversal on the left hand side, and then either right hand side, both the side. And then I try to see if I find the head match. So on the right hand side I did find a head match. So head is equals to root dot well. So when I do a further right tree traversal, I found head is equal to root dot well. Now as soon as I got this condition, I invoke another recursion on the helper itself, and then I traverse head dot next. Basically I go to the next element of in the linked list, which is 2, and then I traverse either left hand side, because the path can be on the left or on the right side, so we have to look at both. If I found a path either left or right, anywhere, I'll just do a OR operation, either left or right. If one of them is true, then it is true, right? So in this case right is none. So basically when right is none, so I'm going to return false, but left is it is there, right? So I do further again, I'll go down in the tree and see head becoming as none or not. So at this, after this particular node, head will become none, so I'll return true. And then if I do a left and right ORing operation, so here it is coming true, and then here it is coming false, so that's going to be true because I'm doing OR operation. And then in this way I keep doing this. So as soon as in the final, again I do for operation, whatever it is coming from here and there this side, and then I return the final result. So that's the overall code. I mean, hope you understand the problem here. So if you run this, so yeah, it works fine for all the test cases. You can just go ahead and submit it. Hope you understand the algorithm and like the video. Thank you for watching.